Welcome to EC Elimu, Learning Simplified, and welcome to this lesson. In the previous lesson, we discussed the laws of reflection, and we said we have two main laws of reflection. And the first law of reflection states that the incident ray, the normal line, and the reflected ray all lie at the same plane at the point of incidence. The second law of reflection states that the angle of incidence is equal to the angle of reflection. So in this lesson, we are going to discuss how images are formed by plane mirrors, and we are going to use the laws of reflection for us to form images inside a plane mirror. My name is Albert. I hope you will enjoy the lesson. By the end of this lesson, I expect you to be able to describe how you can form images inside a plane mirror, and then state the characteristics of images formed by a plane mirror, and then finally distinguish between a virtual and a real image. So the image formation on plane mirrors depend on the three main ideas that we have discussed in this lesson. And the first idea is that light travels in a straight line. Then the second idea is that uh, for you to see an object, light must travel from the object into your eye. Then the third idea that you need is the laws of reflection, where we have the first law as the incident ray, the normal, and the reflected ray all lie at the same plane at the point of incidence. And then you need the second law of reflection, that the angle of incidence is equal to the angle of reflection. Now, if you have the three ideas, then it will be very easy for you to form an image on a plane mirror. Again, before we form images on plane mirror, it's important to know that an image or an object makes an angle of 90 degrees to the mirror. Whenever you are forming an image, the object must make an angle of 90 degrees to the mirror, and then the distance between the object and the mirror must be equal to the distance between the image and the mirror. So if you have these two ideas, then it will be very easy for you to form images behind or on the mirror. And then another important thing that you need is that rays behind the mirror are not real, they are just virtual rays. So if we can now take or have a mirror here, and we want to form an image on this mirror. So if we have our mirror line like this is our mirror line, this is behind the mirror, then we have an object here. Let's draw an object of this shape. This is A, B, and C. So this is our object like that. Then the first idea that you need is that the points A, B, and C, they will make 90 degrees to the mirror. That's what we have just said. So if you have point A, then point A must make a 90 degrees angle to the mirror. So that's how it will be formed. Mirrors form images 90 degrees to the mirror. So if point A now form 90 degrees to the mirror like that, then we have also said the image will be same distance behind the mirror. So in this case, the distance of point A will be the same as in front of the mirror. So here we'll have A prime. Then point B, remember, it has the largest distance from the mirror. So first, it will make 90 degrees to the mirror. 90 degrees to the mirror like that, and then it will move the equal distance behind the mirror like that. So in this case, here it will be 90 degrees, 90 degrees, or even from the back it will be 90 degrees, and then this one will be our B prime, and then we will have a point C, which is the shortest distance in this case. However, 90 degrees to the mirror, and then behind the mirror, same distance and 90 degrees like that. So here, this will be our C prime, 90 degrees at this point to the mirror. So now, if we join the points A to C, A prime to C prime, this now will look like this. A prime to C prime, it will be like that. Remember, we are drawing using dots because this image cannot be touched or cannot be formed on the screen. It's only a virtual image. We want to know the meaning of the word a virtual image. So this one is an image, and this was our object. So this image is not continuous because that image is not formed on the screen, and it cannot be formed by real rays. Now, I want you to observe something. Point C was on the right side. Well, on inside here, it has become on the left hand side. Then point this object is the point A and point B, they lie at the same height. Point C and point C prime, they lie at the same height. So the height of this object is the same as the height of the image. And again, another important thing is that the two objects have the same distance from the mirror. The distance of the object from the mirror is the same as this, the distance of the image from the mirror. Now, I want to take a scenario where now someone with an eye is looking from this point inside the mirror. This is the eye. How will this person see that image? Because now this person, when they are looking inside the mirror, they cannot see this object because light travels in a straight line. Light cannot come direct, it cannot move from this directly to the eye. What this person will see is the image which is formed, which has already been formed inside the mirror. So what this person will see, they will see light traveling from that image into their eye directly. But remember, behind this mirror, there is no light which is traveling there. It's an imaginary rays. So behind the mirror, since they are imaginary rays, we just draw using dots. But now they will be in a straight line, but in front here, it will be a continuous line like that to show that that is a real ray in front of this mirror. But behind we draw dotted because they are virtual rays. Then point C prime will be dotted at the back because the rays are not real there. Then when it comes in front of the mirror, it becomes a continuous line. And then point B prime also will be dotted behind the mirror like that. And then when it comes in front here, it will be continuous like that. But remember, this person is receiving these rays. So in front here, these rays are real. The rays behind cannot be drawn, an arrow cannot be drawn on them because they are virtual rays. So what happens here, this one, we call them virtual rays, rays which cannot be formed or which cannot be formed on the screen. So even this image is a virtual image. Now, this ray that has reached this eye of this person, where did it come from? These rays, or these three rays, came from point A. But when it came from point A, the ray from this point came from point A. The one on A prime up here came from point A. So we can now join the real ray from point A. This ray came like that, and then it got reflected, obeying the laws of reflection at this point in such a way that the angle of incidence is the same as the angle of reflection. Then the ray from C prime also came from C, but when it came from C, let me draw it using a different ink. It came from C to this mirror, and then it got reflected at this point of incidence in such a way that I is equals to R. Then a ray from B prime came from B. Then when it came from B, it got reflected at this mirror like that, and then the angle of incidence also was equal to the angle of reflection. Remember, when you are drawing real rays, you put an arrow on them to show the direction. So here I is equals to R. So in this case, look at this now. This person is seeing the image of this object. So the person will be seeing the image. That's why those rays come from the back of that mirror. How do you see when rays from the object reaches your eye? Now in this case, what is this person seeing? Is he seeing the object or the image? He will be seeing the image. That's why we draw straight line, because light travels in a straight line. So we'll assume the light from that whatever is seeing the image will come in a straight line. But in the real sense, these rays were not coming from the back. They were reflected by this mirror, or the direction of these rays was changed by this mirror into the eye. So for you to draw images in or on a plane mirror, then first thing you do, you first locate the position of the image, and then from the image you draw straight lines to the eye, and then from the eye now you can join them to the respective points in the object. So from the image that we have just formed, we can give now the characteristics of images formed by plane mirrors. And the first characteristic is that the image is erect. Image is erect means the image is upright. The upper part of the object is the same as the upper part of the image, and the lower part of the object is the same as the lower part of the image. This is different from a pinhole camera where we said the image is upside down. If the object was upright in a pinhole camera, it will be upside down. But in this case, if the object is upright, the image is also upright. Then another thing that we have noticed is that the image is as far behind the mirror. The image is as far behind the mirror as the object is in front of the mirror. This means image distance is equals to object distance. And then if you can remember well from the pinhole camera, we said magnification is the ratio of image distance to object distance. Now, if an image distance is equal to object distance, then it means here magnification is 1, because if you divide like 2 divided by 2, if the two distances are the same, then you will get 1. So when magnification is 1, it means the image height is the same as the object height, so there is no magnification in this case. When the magnification is 1, it means there is no magnification. There's no diminishing of the image, or there's no enlargement of the image. Then another characteristic is that the image is virtual. Virtual means an image which cannot be received on the screen. The image which is formed on a plane mirror, you cannot touch it, or it cannot be formed on the screen. It's formed behind the mirror. And then a virtual image can also be defined as an image which is formed by the intersection of virtual rays. So if someone asks you what is a virtual image, you can answer it in two ways: an image which cannot be received on the screen, or an image which is formed by the intersection of virtual rays. This is different from a pinhole camera. Remember, we said in a pinhole camera, a real image is formed, and we define the real image as an image which can be formed on the screen, or an image which can be formed when real rays intersect, or by intersection of real rays. That was for a real image. But for a virtual image, is an image which is formed by intersection of virtual rays, or an image which cannot be formed or received on the screen. Another characteristic is that the image is laterally inverted. Laterally inverted is what we have just seen. You saw the point C appeared on the right side in the object, and then on the image it appeared on the left side. So laterally inversion means left appears on the right and the right appears on the left, and vice versa. So images formed by a plane mirror, and if you have ever used one, if you are in front of a mirror and you raise your left hand, you will see that it's a right hand which is rising inside the mirror. And if you raise your right hand, you will see a left hand rising. That's what we call lateral inversion. Then of course, this one we have talked about it. The image is the same size as the object. So these characteristics, you should be very keen with them, and then you should be able to compare them with the ones from a pinhole camera. Then let's do one example here where we're going to form an image on a plane mirror. Then you will do more questions on ECLM website. So if you have a plane mirror here, you have a plane mirror there, then this is the back of the plane mirror, and then we have now our object here. This is our object. This is the object. And then we have a person who is observing from this point. This is the eye. This is the eye. Then the question is, how will this person see that object inside this mirror? So as we said, the first thing you do, you first locate the position of the image inside the mirror. And for you to locate the position of the image inside the mirror, we said you have to observe two things. The image is formed 90 degrees to the mirror. So you will just draw dotted lines like this, 90 degrees to the mirror on the upper part, and then the lower part of this image or this object is also 90 degrees to the mirror. Make sure you use a ruler, then it will be 90 degrees also like that. Then another thing that we said is that the image will be formed equal distance like in front of the mirror, so it will be cover the same distance behind the mirror as the object is in front of the mirror. So the upper part will cover that distance like that, and then the lower part will also cover a same distance behind the mirror like that. So in this case, now you will form an image, and this image now will not be complete like that one which is bold. It will be dotted like this because the image is not real. So that will be the image. The image will be formed equal distance behind the mirror and 90 degrees to the mirror. So that is the first thing that you do. And now, how will this eye, what would this eye see? Would this eye see this object, or the eye will see the image inside the mirror? In this case, the eye will see the image inside the mirror, and then we ask ourselves, how do we see objects or images? We see images or objects or bodies when light from that object reaches our eye. So in this case, the eye is going to see the image. So light will be coming straight in a straight line from the image to the eye of this person, but behind the mirror there's no light which is coming there, so it's a virtual ray. Then now in front here it will come in a straight line like that. Then below that image, then light will be coming from behind the mirror, but in this case there's no light as I have said, so it's a virtual ray. Then in front here it will come in a continuous line like that. So in this case, this person will see this image in a straight line, and the rays should be coming in a straight line. Then where we have complete rays, then they should be having arrows. But now, how did this ray reach the eye of this person? This rays came from this, reach the eyes of this person. The ray which is on top of this image came from the top of this object. So here you draw a continuous line from the top, joining the line which is coming from the top of that image. And then here, it means if you draw a normal here, the angle of incidence, which is I, will be equal to the angle of reflection R. and then the lower part or the lower ray which comes from the lower part of the image will also come from the lower part of the object in such a way that it's in a straight line to the mirror. Let me draw it with red, excuse me. So if I draw it with red also, this ray will come below or from below this object like that and join this ray which is coming from below or from below the image like that. So make sure when you are drawing this, you use a ruler. So this ray will come like that. Then in this case, it will also be in a way that the angle of incidence is equal to the angle of refraction. This is our I, and this is our R. And now you have to draw or to have an arrow on this image. So now in this case, this person will see the image of this object. The object is 90 degrees to the surface. It is same distance behind the mirror. It is of the same height, and the image and the object are of the same height, but this person will see the object as if it's coming in a straight line. So that is how you form images using or on a plane mirror. First, you locate the position of the image by drawing it 90 degrees to the surface or the mirror, and then now from the image you draw straight lines to the eye, but behind the mirror these are virtual rays. You don't put an arrow on them, and then you don't draw continuous line. Also the image, you don't draw it continuously, you draw dots, but in front of the mirror then you have to draw rays which are continuous, and then you observe the first law of reflection in such a way that the incident ray and the reflected ray, they are lying at the same point or on the same plane at the point of incidence. So that marks the end of our lesson today. In the next lesson, we will discuss rotation of mirrors.